So today I'll be taking you through one example of applying k-means clustering algorithm using the popular dataset Iris. This dataset is commonly used for multivariate classification, and we'll explore how k-mean clustering performance on this data. Let's start by loading the data, and you can see the command is here. Loading and examining the dataset with a quick call iris string. We can see that the dataset contains 150 observation and 5 variables. We have sepal length and sepal width. So we have the petal length and the petal width and other species. The species variable is categorical with 3 levels: uh, setosa, viscala, and the vinica. To get the statistical summary of the dataset, we use a summarized iris, this one here. So if I run, you can now see that we have a glimpse of uh, what we call the measures of central tendency and measures of dispersion. Basically tries to describe our data. Uh, Moving forward, uh, we want to now we want to do the next step, which is basically pre-processing this data set. We need to prepare it for k-means algorithm. We extract the numerical variables into a new data frame called iris new, and that is what we are going to do in the next step, pre-processing the data set. And you can see I'm going to extract the iris new data, and you can see that is the sepal length, and we have the petal length as well. The next thing, to ensure that our numerical variables are on a comparable scale, we apply the normalization function, uh, and that is the next line of code, which is 37 to 45, to perform clustering with the k number of clusters to set 3. So the algorithm calculates the clusters assignment for each record and processes the value information such as the size of the cluster, the coordinates, and the cluster assignment for each record. So if I run this command, you can now see it has calculated all the 3 categories. So now that the data set is processed, we proceed to applying the k-means clustering algorithm. Applying the k-means cluster algorithm, and that will perform clustering with k with the k number of sets. And if I run this command, you can see I have an output here. The next thing is to verify the results. So to verify our results, the result of our clustering, we employed visualization by plotting the sepal length against the sepal width for both the predicted clusters and the original class labels. You can visually compare this distribution. Similarly, you can use a plot of petal length against the petal width. These plots allow us to observe. So if I run the command, uh, the next part, then now I'll run the plots and I can view it in a different page. So the plots allow us to compare, to observe, and allow us to observe how well the k-means clustering algorithm group data points and compare to the original label. In addition, the visuals we create across the tabulation between the predicted clusters and the original species using labels, that is the table. That is maybe the next command, which is here, the next command, the next line of command. So you can see from this point, this is basically a cross tabulation between the predicted values and predicted cluster values and the original species label. This table provides basically an insight into the correspondence between the predicted clusters and the actual species. Overall, the presentation demonstrates the application of K-clustering algorithm to the cluster iris data. We explore the dataset, preprocessed it, and applied the algorithm. Lastly, verify the results using a visual and a cross tabulation. So by doing so, we gain understanding on how well clustering, K-mean clustering performance on these multivariate datasets, and its ability to cluster the iris species based on the numerical attributes.